velocity. So what is velocity? Let us first define velocity. So velocity, just like speed, this is all about how fast, how fast an object is moving. But difference between the difference of velocity to speed is that this is in a specific direction. So we would say how fast an object is moving in a particular direction. Okay, so we should know that just like speed, let's say this is our speed here, and this is our velocity. Velocity. They both talk about how fast, how fast the object is moving. So these two terms, speed and velocity, actually talks how fast the object is moving. But the difference between the two is that for velocity, or this quantity measures how fast the object is moving in a particular direction. So the direction actually really matters for velocity because velocity is actually a vector quantity. While for speed, the direction is not very important. Now, to illustrate further the difference between these two, let us have, or let's say we have here an illustration to better understand what is this speed and velocity and the difference between the two and how to really measure velocity. Okay? Okay, so we have here an illustration. Now we have here a butterfly. This butterfly wants to move from, let's say this is our initial point, point A, and then it wants to move at point B in this plant. Now, the actual path made by this butterfly is the green one. So this is the actual path made. Now, on the other hand, this red line is a straight path, the shortest path that this butterfly can take to move from point A to point B. Now we know that this green line is actually what we call distance. Okay. On the other hand, this red line is what we call displacement, the shortest path to move from our initial position A to our position and final position B. The actual difference between speed and velocity is that for speed, or symbolized by S, is that it talks how fast the object is moving in this particular path. Okay, so what we really want to know in speed is that we wanted to know how fast this butterfly is moving along this path, and this path is what we call distance. On the other hand, for velocity, what we actually wanted to know is, which is symbolized by this one, this total time, is this one. We wanted to know how fast this butterfly will travel along this path, or which is what we call displacement, the shortest path that this butterfly can take to move from point A to point B. That's the only difference between the two. So for velocity, this is displacement. We wanted to know how fast the object is moving along that particular direction or along that particular path, which is displacement. On the other hand, for speed, we wanted to know how fast the object is moving along this particular path, which is what we call distance. Okay, so that's the difference between the two. And we know that displacement is a vector quantity. So this is a vector quantity. This means that it needs direction. Now, if we look at back here, the direction here should be this one. That is the direction. Okay? So that is velocity. Okay. Previously, in my past videos about speed, we tried to graph the speed. Okay, in a Gaussian plane. So this is our time in seconds, and this is our uh, d in meters. This is how we graph the value of our speed. So the speed here is nothing but a slope. Let's say we have here some point. This is a point 1, and then we have here a point 2. So if we were going to connect these 2 points, so this should be a straight line. This is our speed. So speed is nothing but the slope. So it's the slope of this line. Now, on the other hand, for velocity, right, so I need to use black one, the same. So just like speed, so if we graph the value, the only difference here is that, so same with speed, this is time in seconds, but here should be displacement and not distance, but still it should be in meters because that's the SI unit. So if we will still try to graph this one, just for the sake of this example, let's say we start here, end up here. So if I draw a straight line that would connect these 2 points, and that is what I call velocity. So this is still the velocity. Same with speed. This is also a slope. Okay, this is still a slope. Again, the only difference here is for speed, this is our distance. For velocity, this will be displacement. Again, you can derive this these two equation using the equation, the y-intercept form, the line equation. So we have y equals mx plus b, where our y here is the d or d bar, while our x here will be the time, that's the horizontal one. And our m here could be our speed, or it could be our velocity because that is for slope. So we would say, find the slope. We could just simply say that while our b here is the value of y when x is equals to 0. Again, let me say this one. B is nothing is equivalent the value of y when x equals to 0. Okay. Now, in most cases, this is 0. But there are times as well that the value of b is not 0. So our goal here is we would assume that b is 0. So we would say b is 0. In that case, when time 0 is 0, the initial position of our d is, or object, is also 0. Same with here. We would say that at time 0, the object is located at 0. So this is 0, so we could just simply eliminate that one. Now our goal here is to solve for the equation of m, or slope. So we would just simply say y, slope is y mx, okay, because that is 0. Now solve for m, so we could just simply multiply both sides by 1 over x, so that we could cancel out the x here, and the remaining will be m. Okay, so we're left with y equals x equals m. So next we would say, I'll just rearrange the formula. So we would say m equals to y over x. So this will be our equation for the slope, and slope is nothing but the speed. Now for speed, m equals to y over x, we would normally say m as s, and for y, this is actually d. So that's d. So we could say change in d over, for x, our x here is the time. So change in time. So this will be our equation for the speed. On the other hand, for velocity, okay, for velocity, the same equation, we're just changing the variables here to fit to our to the variables we use in our Gaussian lines. So instead of m, I would say v, still the slope. For y, the y-axis in our coordinate is displacement, so we would change y to d bar. So change in d bar over, our x-axis is still time, so we would still say this is change in time, and this will be our equation in solving for velocity.